Hello everyone, welcome to this session. I'm Lucas Duarte, a container specialist SA with AWS, and today with me I have Thiago Reichert, also a container specialist SA here with AWS. Thiago, want to introduce yourself?
Hey folks, as Lucas mentioned, I'm currently a container specialist SA here at AWS and currently focused on helping startups here in Latin America with both containers and SaaS or software as a services best practices. Lucas, why don't you take us over to the presentation?
Alright, so in today's session we are going to cover from chaos to control, how to structure your GitOps repository for a scalable GitOps on Kubernetes approach. So with that, let's get started. It's important to understand that when we are deploying applications on top of Kubernetes, it's not just a matter of picking the right orchestrator, right? So it's not just like I want to run Kubernetes. There's a lot of steps that you need to do in your cluster in order to start to deploy the applications. So the Kubernetes journey starts like that. You pick your orchestrator, in this case Kubernetes, then of course you launch your data plane, the compute capacity where you're gonna actually deploy the applications. If you're talking about AWS, we can use Amazon Managed Node Groups or even Carpenter for a more application scaling first mechanism. Then after that, there's something that's pretty important, which is essentially our cluster add-ons. So whatever we need to install in the cluster to be able to make the applications work in the way that we're expecting in an automated fashion, this is where we need add-ons. So for example, metric server is one add-on that we need in order for HPA to work, and so on and so forth. So when you are dealing with Kubernetes, you will need a set of those add-ons. And of course, after that, you deploy your application, but there's a challenge that comes without that, day two operations. And you could end up feeling like that. Actually, you're gonna end up feeling like this, cluster upgrades. When you deploy software on top of your Kubernetes cluster, add-ons and applications, you need to make sure that you are prepared for upgrades. So that is a challenge that multiple companies face because they don't have a structured way of operating those clusters at scale, of distributing add-ons at scale, of centralizing or creating patterns and blueprints of applications in order to be able to change those API versions when they need to move to a next version of Kubernetes. And again, the more clusters that you have, depending on the structure they have created, harder it's going to be for you to do cluster upgrades. And now, of course, we need to talk about the operational model evolution because essentially we have two different types of teams. One is the application development team, and the other one is the infrastructure and operations team. Usually, those two teams, they have very specific responsibilities when we are talking about them. The infrastructure and operations team usually takes care of the infrastructure layer and also sometimes of creating the YAML files and deploying those YAML files into the cluster that the developers have asked. But in this case, infrastructure layer. And the application and development teams will be responsible to the application logic that sits on top of that. And most likely, every application will need a piece of infrastructure as well. So, along with the Kubernetes challenge in the two operations, usually the teams that support those clusters at scale, they will also need to create infrastructure resources for application development teams. So when it's one team, it's fine. The one team will send a request, the infrastructure and operations team will create those resources for them. But what happens if another team comes in, and another one, and another one, and another one, and so on and so forth? Those folks in the middle, they will most likely become a bottleneck. Not because they are not smart, but because people cannot scale. What can scale is automation and practices that we put in place in order to support those developers. So we could be asking, okay, I understood that Kubernetes upgrades is a challenge, day two operations is a challenge. DevOps and infrastructure engineers, they have another challenge, which is essentially developer asking for too much and the team doesn't have the capacity to handle all those requests. At the same time, moving the stack and improving the process of the stack. So that team will most likely become a bottleneck. So how can we solve that particular problem, right? Essentially, the infrastructure and operations team, they will take care of CI/CD, monitoring, security, infrastructure as a code, and any other thing that is related to your company that is up to the infrastructure and operations team to fix. And of course, developers will just take care of the code base. So how can we solve that? I would say we can simply shift left. But if we shift left, what's going to start to happen is every developer and team can implement their own patterns and own stuff. So the code base is different for every one of them, but maybe for CI/CD, one is going to use GitOps, another one's going to use Jenkins. And then maybe for monitoring, one team is using CloudWatch, another one is using Grafana. And then if one team can help another one in some automation that they created, they're not going to be able to do that because they are basically aligning the automation to their specific use case. So what's the idea here? We need to shift to left, but we need to empower them with platform engineering assets. So instead of let them do whatever they want to do, we're going to create those blueprints and patterns that we're going to dive deep in today's presentation. And then we are going to offer them those blueprints and patterns. They will simply consume those blueprints and patterns instead of creating their own set of assets and automation the way that they want to use that. So we're talking about infrastructure. We're talking about the two operations. We understood that infrastructure and operations team often will become overloaded with that amount of requests. And also when we're talking about upgrades, we need to understand that YAML files are replicated most likely across multiple application repositories. So application development team want to deploy an application, will most likely need an HPA, a deployment, an ingress, a service, a config map, and so on and so forth. Next team will most likely need the same thing. Next one, the same thing. Next one, the same thing. So if we look at how those application development teams defining their own YAML files, that will lead to cluster upgrades. That will be a problem as well, because if we are defining YAML files across multiple different repositories, and then once we need to update those API versions or even the API or even the YAML structure, cluster upgrades can become a problem if you don't have a centralized way to do that. So a way to overcome that challenge with blueprints, going back to what I said in previous slide, is essentially we can use Helm charts, for example. That's one way of solving that. So instead of the developers defining their own YAML files, the platform team will be responsible to create and maintain one or multiple Helm charts. The development team will implement their own values.yaml file, and then it will make the Helm chart behaves in a certain way. But this is for just the applications. We talked about infrastructure previously, right? What we can do with infrastructure. Essentially, the infrastructure as a code landscape is pretty big. So we have HCL, JSON, YAML definitions like Terraform or even OpenTofu controller and CloudFormation. We have code as well, so we can use Pulumi or AWS CDK. And also we have custom resources. So Kubernetes controllers that allows us to provision infrastructure resources from within our Kubernetes cluster. So for today's session, we're going to be focusing on that more Kubernetes native way of provisioning infrastructure resources, who is essentially using controllers. And since we're using controllers, and controllers are just like any other YAML file that we can deploy on top of our cluster, what essentially we can do is we can embed that custom resource of the controller that we picked. Again, we are not specifying any specific controller, but ACK, Crossplane, or even OpenTofu controller would allow you to create those custom resources, and then you can embed those custom resources into your Helm chart as well. And then if you have a modularized structure for your a blueprint structure for infrastructure assets, you essentially can let the developers pick whatever infrastructure resources they want using the blueprints that were created by the platform team. Using the blueprints that were created for the platform team. So instead of then keeping track and sending messages to the application, to the platform team, asking to create infrastructure resources, to define YAML files, to update YAML files, we're going to centralize all that into a Helm chart, and that will help us a lot during upgrade times, because essentially now the platform team have the control over the manifests, and they can update and roll out those manifests across multiple applications. And I'm going to send over to Thiago, and Thiago is going to help us to understand how we can scale this at multiple clusters, because as of now, we're just talking about blueprints. Thiago, up to you.
Yes, Lucas, I agree. Having a consistent way to package your application is pretty important. But it's not just about packaging the application. You might have to deploy this application into multiple environments. For example, you might have your development environment, your QA environment, and also production environment. And you have to replicate these applications first to development environment, and after you have tested it, or if you have finished to develop, go to QA, test the application, and then move these application changes to production. You might also have to replicate some of those environments, for example, having the production environment in a second region for a disaster recovery strategy. And it's not that simple. Each of those environments, for example, the production environment might have multiple applications running. If you have a microservices strategy, you might have multiple deployments here of your applications for each of your microservices and also the add-ons that support these applications. You might have, for example, observability add-ons, security add-ons, and so on. So how can we consistently apply those changes when we have a new version of our applications across those environments so that we can have all the environments up to date? One way to do that is using GitOps. And I think it's important to notice that GitOps is not a tool itself, it's a concept. And the idea is that you have a single source of truth inside of your Git repository on which you have all the changes that you do to your applications, and you can build an immutability firewall. The idea is that your GitOps tool of choice, it can be Argo CD, Flux CD, for example, both open source CNCF backed projects. You can configure this to only this tool be able to deploy into your production environment, for example. With that, you have all the changes that went to your production environment in your Git repository. You have all the history of changes, and you can also easily roll back if there is, for example, an issue with an update of your application. But it's not just about picking the tool you want to use for your GitOps strategy. You also have to define how to structure the repositories and folders for this strategy across your environments. One way to go is having a MonoRepo. You can have a single Git repository for all of your applications and all of your environments. But soon enough, you might realize that with this model, it's hard to have fine-grained access control. For example, having a control on which user can, for example, do changes to a specific environment, for example, whom can do changes to the production environment. A few issues can happen, for example, someone changing a file in the productions folder instead of doing that in the QA folder and causing outages. So a way to overcome this challenge and having a more fine-grained access control is creating a repository by environment. Now we have a fine access control. We know who can do changes to the QA, to the production environment. And now we have all the applications for each environment in that Git repository with the add-ons to support those applications as well. But soon enough, you might realize that you can have another problem here. And it's again about cluster upgrades. When there is a new version of Kubernetes and you have to update your applications and add-ons to support this new version of Kubernetes, might say there is a deprecated API in this new version and you have to change the add-on version that you are using. How can you do that in a consistent way? Right now, you have your add-ons in each of the Git repositories. Now you have to go to these multiple Git repositories and change in these multiple Git repositories to use a new version of your add-on. What you could do is have a centralized add-ons repository on which you can manage those add-ons and the versions of those add-ons, the configuration of those add-ons, all the manifests, and just in each of your environments, Git repository point to that centralized add-on repository so that you can have still a centralized way to manage the add-ons, but have the fine-grained access control across your environments. And a way to implement that, let's say we will have, for example, here a Git repository for one of our environments. We will have there the add-ons reference. We will be referencing our add-ons in a specific version because you might not have all the cluster running all the time in the same version across your environment. So you still need a versioning for add-ons. We will also have our microservices, for example, the product and catalog microservice. Here we are defining a Helm release. We will be using the Helm chart that Lucas mentioned to us earlier with all the packaging on how to deploy the application and just specify some parameters here, for example, which container image you want to use, what is the request that we want to use, for example, on memory and CPU, and also which infrastructure add-ons we want to deploy. After we define this in our Git repository, our GitOps tool will see those changes, reconcile those changes, and create both the Kubernetes resources to deploy our application, but also the objects that define the infrastructure. And now our infrastructure controller will see those changes and also apply and create the infrastructure inside of our AWS account. For example, creating the S3 buckets and DynamoDB tables and so on. And if you want to dive deeper into those concepts, we have this workshop that we built that talks about how to build a SaaS or software as a service application on Kubernetes using GitOps. We cover concepts such as how to package your application consistently, how to onboard tenants, how to define a tiering strategy, and also how to apply changes across the environments in a consistent way using GitOps. So refer to the QR code if you want to dive deeper. Thank you all for the participation and have a great day.